All right, so I kind of already started the discussion. This is about functional programming and business. Now, there's actually quite a lot of hype about functional programming right now. It's kind of exploding. Has anyone experienced the hype? Yeah? What have you heard about functional programming? Yeah.
Essentially, since Moore's law is dead, we need to move towards functional programming in order to continue speeding up and building problems that can be broken up into pieces.
Cool, thank you. Anybody else? Cole?
Amazeballs.
Amazeballs, all right. Yeah. So there's pure hype, no content. Yeah. Okay. Anything else? Yeah.
You're in the cloud, there's parallelization.
Parallelization, yeah, okay. Cool.
We have a lot about programming more expressive and able to express ideas more.
Okay, yeah, I've heard that one too. So it's more expressive, maybe more declarative, maybe, I guess that might mean shorter programs to do the same thing. Okay, so all of those things are true. I'm going to say that, including the content-free one, Amazeballs. But right now I want to focus on business. You know, it's really cool to hack on something in your spare time and have fun with it, and it being amazing and balls, Amazeballs, see. But there's like a practical side to business where, you know, you got to have a real reason to use it. So that's what we're going to talk about. Also, there are some things I'm going to say that I believe, but I don't have a citation for. Like, I cannot point to something like, this is where you learn that this is true. Most of this is from my personal experience instead of, you know, a paper or somebody else's experience that is maybe better documented. So I'm going to put this on just like you see on Wikipedia everywhere. We still believe Wikipedia, right? Even though it has citation needed. All right, so this is another question for the audience. What is functional programming? Y'all are here. You must have some idea. Anything, no wrong answers.
Side effects, free, program with just setups with functions. That's it? Like as a thing.
Cool, thank you.
Is it a fixed term?
Maybe it's not a fixed term. Oh, you're asking me. Well, I'll answer it, but I want to hear the audience.
Okay.
Yeah.
Given the same inputs, you always get the same output.
Cool, nice. Yeah.
Maybe you're focus on definition of mean about composability.
Composability. Cool, nice, nice. Well, I'm going to. No, I'm just going to oppose it to object-oriented. I'm not saying that that's the definition, but I kind of tune this for kind of businessy folks that might be like, what is the difference? Well, it's not object-oriented, and as we had some great definitions, and these are all correct. Like, I was hoping for one that wasn't correct, that I could be like, you're wrong. But I couldn't, so boom. They're just loosely, like, there's some ideas in it that are just kind of connected, that all go together just by circumstance, that there's no, like, way that you could say, well, object-oriented is classes and methods, you're done. It's not so simple. One thing that is kind of common among functional programming languages is that it's kind of math-oriented. Things are, you try to do stuff in terms of functions and mathematical functions. Use immutable data. This is common but not universal, but it means that you have a piece of data and it can never change. And if you want to change it or you want something modified, you have to make a copy of it. So this is very common in functional programming. And we'll talk about the business implications after this. And then functions, instead of using classes to abstract, you're going to be using functions. That's very common too. And that's where the functional comes from. All right, so enough about the technical side of what functional programming is. Doing business. Like, what's the purpose of functional programming in business? How can it give you an advantage? Should you even be thinking about it? Like, just cut it out of your life. We don't talk about functional in this company. So, who runs a company? Cole? Yes, I don't know your name. What's your name? Sorry?
Bernard.
Bernard. What company? Is it software?
Strategy.
Okay. And you do software?
No. Yeah, it's represent Fusion software in New Orleans.
Okay. Somebody else? I saw a hand over this side. Yeah. Okay. So we have some businesses. That's great. That's just really who this is targeted for. Is business people who are trying to make a decision. So let's talk about hiring. This is a really hot topic in functional programming because there's this perception that you would, like, for instance, let's just use PHP because look how many PHP programmers there are. There must be a ton of great ones in this giant pool of like 10 million people that know PHP. So let's talk about the reality. This is not to scale, but if you have this many object-oriented programmers in a group, you're going to have that many functional. Okay, a really small number compared. But this isn't like the whole story. A lot of people talk about this, but here's the real story. There's this procedural, is this other huge thing like towering next to object-oriented. And this is citation needed, but I bet that most programmers, even though they know how to use like the dot syntax and make a class and stuff, they're not really object-oriented programmers, right? They're still doing procedural, but they know how to call methods, right? They know how to organize stuff into a class. So most people are in here, right? But we still hire people who we want them to be object-oriented programmers. So is it harder to find functional programmers? Yes, it is. It really is harder. But as a business, that's not your main concern. Your main concern is it harder to find good functional programmers? Right? You don't want bad programmers. They're going to drag you down. So in green, we have the good functional, or the good programmers. So if there's this many good programmers in the procedural, it's going to be hard to find the good ones because you're going to get a bunch of resumes. You're going to say, oh, we need some Python programmers. And you're going to get 1,000 resumes and only this many, I don't know, it's not to scale. Only 100 of them are going to be good. So out of 1,000, you're going to get 100 good ones. And I just got rid of the procedural so we could see. This is another citation needed. The proportion of good programmers who do functional is higher. I put it at about 50%. Here, this is about 20%. Okay, so if you're hiring and you say you need Clojure experience, you need Haskell experience, those people are going to be better on average than your object-oriented programmer. Okay, so even if they're not in the top 10% of functional, they're already in this group, right? This whole group would fit in here. And one of the reasons is, for instance, with object-oriented, like every university teaches Java or some object-oriented language. So you've just got this huge number of people who can claim and have a certificate that says, I'm an object-oriented programmer. And very few universities teach functional, so it usually turns out that this is their second or third language. So they're already at that level where they're learning a third language. So that's something to keep in mind when you're hiring for a programming job. Like functional could be a good filter to find those good programmers. Now, here's a question though. Does all software need good programmers? Like, some stuff is becoming so easy nowadays, like setting up a WordPress blog, right? And then tweaking some, theme stuff. You might not need a great programmer for that. You might want to focus on something else, like they're a good designer, right? And that they have programming skills, but they're not great, but they have great design skills. So this is something to consider. You want good programmers for hard problems. So if you're not solving hard problems, you probably don't even care if it's a good programmer. You just want someone who can get the job done, if the job is not hard. All right, another thing about hiring is functional programmers are a little bit more expensive on average if you look at like years of experience and stuff. I looked for some good data on this, but it's mostly anecdotal. But it has to do with that good programmer thing, that someone who has gone to their third language and is putting themselves out there with extra skills, they're going to be a little bit more expensive. But here's another thing that you need a citation for. You need fewer. I'm sorry, I forgot your name. Chris. Chris mentioned that it's more expressive functional programming. So very often you can do more with less. You're not dealing with the same number of bugs. You're able to write code faster. So you often need fewer people. Okay. Code quality. This is another one of those hype things that functional code has fewer bugs, especially a language like Haskell that has a super awesome type system. It can catch so many bugs. You can encode things that will never happen. You can encode away things, so it's impossible. The code, you won't even compile if it has bugs. So let's talk about the reality. I don't have a citation, but I'm sure there's one for this. The number of bugs is correlated with lines of code. The bigger the code base, the more bugs you have. And it's pretty linear. It's just like a straight line. And this is called the defect density, right? And different companies have measured like, oh, well, we have a defect density of 10 bugs per 1,000 lines of code, and they look at their bug tickets and like how big their code base is at the time the bug was found, that kind of thing. And Microsoft has this, and another company has that. Uh-oh. Okay. All right. So here's one. I'm going to go out on a limb, and I'm going to say functional code is significantly smaller. Not like 10%, but we're talking like 1/10. Okay, maybe 1/5. Right? That it's a small fraction of the size of an object-oriented or procedural system. This is from my personal experience and talking to other functional programmers, people who've done a rewrite. They say, wow, we rewrote this and we couldn't believe how small it was in a functional language. All right, so this is the factor one. Functional code is significantly smaller. Oh, right, so number of bugs is correlated to the lines of code. Functional code is significantly smaller. Therefore, functional programs have fewer bugs. Okay, just because they're smaller. I'm gonna assert that as like, if you just multiply it out, you got this. And it's significant because it's like 1/10 the size. All right, so we talked about hard problems. What are some of the problems where functional programming can use its strengths? We talked like a WordPress theme, you don't need functional programming. You need more design chops, that's the important thing there. So what are some things in the business that you would need it for? We talked about immutable data. Auditing is good for immutable data because you don't change anything. You can just record the old stuff, right? So what are some businesses that use auditing? Banking. Insurance, what did you say? Auditors. Healthcare, yeah. Anybody else? Something else? There's some, you know it, you just haven't thought of it. Okay, accounting, banking, medical records, wow. Airplanes. Airplanes record everything that happens on the plane so that if it crashes, they can blame somebody. Science. You want to record all your data as you're gathering it. So all these things, they really benefit from functional programming for that aspect, for that immutable data aspect. We talked about how it's mathematical, functional programming. What are some businesses that use a lot of math? Oil and gas, banking, statistics, data science, yeah. Engineering, finance,
Utilities.
insurance. Okay, so a lot of these are the same. There's an overlap. Science, advertising now, right? Like now it's like you're doing these real-time auctions and figuring out the statistics of which ad to show. Web analytics. Cool. All right. Now another factor, we talked about how it's distributed. You guys like guessed everything I was going to say at the beginning. I don't even know why I'm talking anymore. I should stop. Oh, I didn't make them appear one at a time. Oh well, here you go. So big data, analytics, real-time analytics. You know, you could always do it slowly on one machine, but you want to distribute it because it's got to be real-time. Communications.
Processing.
What's that?
Image processing.
Image processing. That's right. I'll promise to put it on next time. Okay, so those are some of the business cases that functional programming has been applied to successfully. This is one of those things that, like, in bigger businesses, there are often these like bugbear problems, like something that they've tried to solve multiple times. They've like put a team together, they try to do it, and like 2 years later, they're still working on it, and they're doesn't look like they're making any progress. And they just cut the program. And then someone else will come in a couple years later and try to rewrite this system so it's not such a mess. Those kinds of systems, very often, the problem is the methods that they're using are just they're not suited for it. And if you come in with a new method, say functional programming method, you can actually make progress on it. There's actually a talk about this. This man, I didn't write down his name. I can't remember his name. It's on YouTube. You can find it here at this link. But he was working for a large insurance company, and they had this XML test case system that, like, it had tons of bugs. It was super costly to maintain, but they couldn't get rid of it. Like, they were just resigned to using it for the rest of eternity. And he said, look, just put me on it alone. It will be cheap because it's just one employee. I'm going to work on it, but I'm going to use F#. I'm going to go through and use the mathematical methods that I know to analyze this, to make sure I'm capturing everything properly. And it's a great talk because he explains all the cool stuff that he did, that because he was given sort of carte blanche, he was given all this leeway, he could use all these methods that you like learned in school or could read about in a paper and didn't have to convince your manager to do, So I feel like there's this opportunity inside of a business, especially a large enterprise where they can just let someone work on something like this to solve these big problems. He was very happy because he was using functional programming, and the business was happy because he had gotten rid of this like terrible system that they had. Another case where it's useful is in places where there are no pre-existing solutions. There's a thing called the curse of Lisp. Has anyone heard of this? Curse of Lisp? Okay, I'll explain it briefly. Lisp is a functional programming language, the oldest functional programming language. And there's always been this curse, and it's a curse because it's one of those like, oh, it's like mysterious, but then it's brought on by itself, like a self-fulfilling curse. Anyway, you look at languages like Java, and there's like millions of libraries, open source libraries for doing all sorts of things. And then you look at Lisp, which is considered by a lot of people to be way more powerful than Java. But where are all the libraries? Like why, it would be easy to create this library in Lisp and much better. It would be short and like, you wouldn't need many people to work on it. And so the curse is, the answer to this question is, if the language is so powerful, a single person could solve their problem themselves and not need to collaborate, because Java makes it so hard. People have to form a team and make a solution and work together on it. And so then you get a library. Whereas with Lisp, people would just write the 5 lines of code it takes to get their problem solved just right there in line. They wouldn't make a library for it. They wouldn't share that code. So the curse is, it's for existing solutions, Java probably already has a thing where like in 20 lines, 100 lines, you could solve the problem, right? But for non-existing solutions, you want the curse of Lisp, because that's where it shines. Something where we don't know how it's going to work. We know that no one's done this before, but we can write it short and sweet in a functional language. Also, complexity. Functional programming is great for dealing with complexity. Who knows the idea of incidental and external complexity? Okay, so incidental complexity is you're solving a problem. If the problem is complex already, that's incidental complexity. It comes from the domain itself. But then there's the complexity that you're bringing because your technology is complex, and you don't want to compound the two. You don't want to add them together. So if you've already got a really complex problem, you want something that's simple, meaning it doesn't bring a lot of other problems to the table. So for instance, mutable data is a problem. Non-thread safety is a problem. Those kinds of things, you don't want to bring those to an already complex problem. GUIs. It turns out that a lot of GUI programming is easier in functional programming. This is why React is getting popular right now. It's just much easier to say, this is what I want it to look like based on this data, and just do the transformation from data to GUI. A lot of GUIs are like that. Some of them are not, but like if you wanted to make a graph, right? It's much easier to just plot the graph each time as the data changes than to go in and mutate objects and stuff so that the graph is now correct. It gets out of sync with the data. Okay, a little summary. This is it. If you've got hard problems, you want smart people, and then so you want smart tools, or sharp tools. The smart people probably want sharp tools. They want something that they can do more with less. If you want to solve hard problems, you want smart people. So they're gonna demand the sharp tools. Any questions? I hope I didn't say anything new or surprising. Was anybody surprised by something? Was this totally obvious to anybody? Hunter? Yeah.
Reverse question. What would you not want to use?
Good question. Good question. So anything that is similar to that WordPress problem. There's also this like paradox of, I guess it's the paradox of Wikipedia, right? It's like a super successful project, really big, tons of users, and it's written in PHP, right? And you're like, why would I ever choose anything else besides PHP? Look what they've done with it, right? So there's this, all right, but let's compare it to Rails, right? Like not compare it to functional programming, but compare it to Rails. Would Wikipedia be better in Rails? No, probably not. So you wouldn't even go from procedural to object-oriented. Like there's no reason to switch. And also, like when I first saw Rails, I was really excited. This was cool. Like web programming is going to be much easier in this than it is in PHP. And it was cool because it had all sorts of stuff built in. And then like 2 months later, 2 months after I found Rails, I was using WordPress, and the new version of WordPress came out, and it had all those features. It had a flash message. It had like interactive menus and stuff. Now you know how they did it is they just had a bunch of PHP programmers pounding on it. Whereas in Rails there were nice abstractions for everything, and it worked well. But in WordPress they just threw more labor at it. So anything that's like, I guess, digging a ditch, where you can just hand out more shovels and it'll get done faster, you know, that's the kind of thing where functional programming just won't apply. Like that. But if you want to give someone like one of those like cranes, or what are they called? Like a backhoe. Yeah. If you want to give someone a backhoe, you give them a functional language, right? And you give that one guy can drive it and like can dig a whole ditch.
But to push back on that a little,
Yeah, sure.
when you start digging ditches with 100 people at a time, then everything looks like it's comparable with, everything looks like a ditch that you can dig with 100 people, when it really would be better to have a backhoe from the beginning.
Right, for
and,
sure.
You know, if you already have invested in a backhoe, if you've already invested in a table saw, like if you have a table saw at your house, it's almost never worth it to just use a hand saw when you have a table saw at your house, right?
For sure.
So if you're doing this kind of stuff all the time, and I'm in medical software, the problem is that these giant companies think, well, we already have 2,000 software engineers. We're just going to keep throwing 2,000 software engineers at the problem. And there are some problems you simply cannot solve that way.
Right.
But they can't see that because all they see is these ditches that they can dig with. Like, we have 2,000 people, let's just keep digging ditches with 2,000 people.
For sure. And to expand on that and use the analogy I used before with Rails versus PHP, I mean, Rails changed the web, right? Like, the idea of Web 2.0 couldn't have happened without Rails. And so even though it happened with Rails, they kind of backported it, to PHP using just brute force. And I'm still waiting for that to happen with functional languages. It will, where there'll be something like, wow, this is cool, we couldn't do this before. Now that we have functional languages, it's possible. And then people will try to backport it. And maybe they won't be able to backport it, or maybe they will with enough force. Right? Yeah, Joe.
So given the current ecosystem of functional languages and the paradigms, ways of thinking and doing things functionally, would you say a bad functional programmer would still somehow be a little more effective and accomplish a lot of things you're espousing as features of functional programming compared to a good object-oriented? Could a bad functional programmer still be of the same-ish value, just by the way that the tools work?
Well, if I had chalk, I do have chalk, I would draw some normal curves. So I would say, okay, there's your distribution for object-oriented programmer, and just to continue what I was saying, the distribution for functional programmers be like that. And so you still have a lot of overlap on this bad end, right? So yeah, there's definitely it's definitely possible that someone claiming to be a functional programmer could be worse than like the majority of object-oriented programming.
I guess I'm thinking more in terms of tools to compile. Like if you were doing Haskell, you use some eliminating a lot of bugs. So if possibly you're not good at it, the compiler helps you be better at it. By the way, it just sort of works and trains you up. You don't quite get a lot of that with a lot of at least dynamic object-oriented programming languages.
Right. Well, so one thing I've heard with functional languages, especially something like Haskell that has a lot of type safety, is that it gives a really great programmer a lot of leverage because they can hire one like superstar and then hire a team of 10 middling Haskell programmers who can't mess anything up. So this one person is setting everything up so that the others can get work done without messing anything up. So it does have that same like ditch digging idea to it, that like you only need one person out here and then like a bunch of people in this area, and then you're multiplying this person's effectiveness. So I've heard that kind of model working.
But don't you think, I mean...
I'm sorry if you can't see.
That's okay, I gotcha. Don't you think, though, that, I mean, it's not just the programming language there, because, I mean, for them to be able to break apart the project for 10 people to work, I mean, Haskell's notorious for people who are, like, pure academics and don't actually ever apply, you know, or accept people in, and they like to have their secret code, their secret set. So it's almost like the language itself becomes the barrier to having more people work on it.
Sure. And so I worked in Haskell for a while, and I felt that a lot.
Yeah.
That there were parts of the code that I could not understand because I would have to read 10 papers, or you know, I would have to go dig into fragments all around the web to understand what is this thing doing and this other thing happening in there. It's like a monad transformer and like and I don't know what a monad transformer is. So there's like documents on it and you have to. So anyway, yes. But the thing was, I was still productive. Like I didn't have to understand the monad transformer. I didn't have to make my own. I just had to know how to work within the type that was created with that monad transformer. So I do have a lot of sympathy for this model, even though I'm also like I have more of a democratic view toward programming, that like anybody should be able to do it, and obfuscating it is bad. So yeah, I'm torn too.
To kind of address that at another point, I'm going to say that in my work I found even doing like very advanced object-oriented patterns, you get like more junior programmers or less experienced people that they can't follow along with it. It's not to say that because it's accessible, they just don't know what it's doing. So you have to teach people, like, to someone that hasn't seen either of them, a dependency injector is just as complicated as a monad. Like, neither one of them really makes sense if you explain the abstractions going on around it. And kind of with the chart there, I don't even necessarily think it's the case that like great functional programmer is as good as, or like a super great object-oriented programmer is the equivalent of like an average functional programmer. I think that a great object-oriented programmer becomes a functional programmer. Like you start to mix your paradigms and get better at using the right tool as you become more experienced in any paradigm of programming.
Did you Cole?
Yeah, I've just seen several of your functional programming talks, and I'm always curious about kind of building on that as well. It's like interweaving object-oriented and functional programming, especially when it relates to places where you can't very well choose the language due to hardware constraints, drivers, a lot of things that some people deal with on a daily basis, and just kind of like this idea of, from a business standpoint, if you want to be more functional and hire more functional people, but you're in an environment that is inherently not typically functional, how do you go about that? Is it like a paradigm in the company you would set up to practice these things, or?
Well, yeah, and that's a good question. So when I talked about like what functional programming means, notice I didn't say it's a particular set of languages or anything like that. I think that someone who is good at functional programming, if you bring them into another environment, they're going to bring those tools and techniques that they know of, and like often, if they're good enough, they will know how to like write their own map, or write their own reduce, because it's not a complicated thing, right? And so they're going to start like functionalizing wherever they're at, right? So whatever tool they're at. Now, you did mention different environments. So like if you're in an embedded environment or something like that, like that's a super constrained kind of thing. Is that the kind of thing you were talking about?
Yeah.
You're talking about maybe like web.
No, I'm thinking more like compiler, or like you are on a specific platform, like embedded,
or like you have to use iOS, you're using Objective-C.
Or you have to use like straight vanilla C or something. But also on that, like you're looking at those kind of constraints, one of the big things of functional programming is immutable data.
Right.
Well, it's very important that you use mutable data whenever you're in
For sure.
a C language, because pointers are your friends. Like,
And that's one of the things about one of the reasons why functional programming is actually becoming more popular now is people have a lot more memory. And they've got these cores that are just idle. And so you could just put more garbage onto the garbage collector, just like let it figure it out and do extra work because you've got more processing than you need. But if you're in these constraints...
So that's great for a massive web distributed system.
Sure.
But not...
Well, it's all about the techniques. So like, unfortunately, I don't know of like a really production-ready, awesome like scheme, embedded scheme. There might be one, right? Hunter might know of one because he's into that stuff. But like, for instance, it compiles to C,
Right.
So it is C, if that's the constraint. And it's oriented toward embedded systems, which means it produces a lot less garbage. It is going to use mutable data. They've just said you're not going to... A scheme has always been mutable. But you're just making that trade-off, right?
Rust.
Well, then Rust. Rust uses a lot of functional programming stuff, and it's supposed to be very efficient.
And to sort of follow that up, you can always have your mutable kernel. So you can always have functional programming doing what functional programming is good at, and then draw the line and be like, this is the part where I need to run 10 million transactions in the GPU. I have assembly code for it. Like, we're not going to be able to beat the speed, memory efficiency of that. But that's fine. Maybe you have 5,000, 10,000 lines of assembly instead of 1 million lines for your whole program.
Right.
So you have this, use the tool that's made for what it's good at. When you're solving conceptually hard problems, maybe that's not the computationally hard problem. Mm-hmm. You have to pick where you're going. Because one tool's obviously better than the other.
But then there's also stories of people writing stuff in assembly because they
think it's faster.
Right, they think it's faster because in micro benchmarks, it's like, look how fast I can make this loop, right? It's like 3 instructions. But then when they have 1 million lines of it, like it actually turns out that they're re-rendering stuff 100 times a frame, and they don't know why. They can't debug it. Whereas if you wrote it in a high-level language with garbage collection and everything going on, it's really fast.
John Herrick, the guy who was the F-sharp talk, he did.
Oh, you saw that talk?
Yeah, so he can beat a Fortran benchmark, which is like one of the top numerical languages in a managed garbage collected language, because he was exploiting this higher level parallelism that the lower level language couldn't figure out. Right. And so he could do a lot more work, even though he was being less efficient with his machine.
Right, and it's just him versus like every Fortran programmer ever to try this benchmark.
Yeah, because it's this, for numerical computing, Fortran's the standard. They still use it for physics. So it's one of those change of mindsets.
Right, it totally is. Like, you talk about parallelism. I've heard of stuff like a Java team versus a C team, and they were benchmarking to say who's faster, Java or C, and the Java team beat the C team. And then they looked into the code, and the C team was like, "Hey, no fair! You use threads." And then the Java team was like, "Well, why didn't you use threads?" "Oh yeah, because it's really hard, right?" And you know, it's not like they couldn't have, but it's like we're not going to go there. We got a limited time, you know. But the Java people were like, "Oh, new thread run," and they were done. So there's stuff like that when you switch to functional, where it's like you're using higher order stuff, and you're able to do stuff like optimizations, dynamic programming that you wouldn't even want to think about. Like React is a great example. When you go from JavaScript React to Clojure script React, where you're using all immutable data structures, it actually becomes faster. Because even though immutable data structures on their own are slower, you know, if you just like compare the operations, because they're in a tree and they share structure, comparing them is very fast. So you can tell if something is changed because it's just a pointer comparison. Is this the same? We know that the whole tree hasn't changed. So the only way to change it is to change that one pointer. If they're the same, you just skip it. You say no change. Whereas in JavaScript, because you've got this mutable data, you have to go walk it and like ask, "Oh, are you the same as before?" So it becomes faster because you're at a higher level.
Another interesting thing like that is that modern compilers are much better at analyzing those kind of things. And even with immutable data structures and linear types, a smart compiler can look at it and see that like, oh, this is the same piece of memory, and it'll make it mutable internally, even though it appears immutable in the language.
Right. Like this never exits this code, so I can make it mutable.
And like as a compiler gets smarter, your code gets faster automatically, whereas your assembly code will always be exactly what it is.
Right.
Never get any better without someone before you learn the right lines of it.
Right. And then there's always the thing that, you know, it used to be that you would hand tune your assembly because you could read the book and figure out, oh wow, this thing takes 8 microseconds and this thing takes 9. So if I do it first, it'll be ready and the bus will be free. And like you would think about all these things, right? But now with like branch prediction and all that stuff, like you can't even predict what the processor is going to do. So all that hand tuning stuff doesn't work anymore. Okay, anything else? Because I'm almost out of time. Last question. Awesome. Thank you very much. You was in time.
All right, I was going to say, one of the conversations we've had at work about hiring people for functional programming is that it goes back to that debate of like there aren't many functional programmers, so like if you put an ad out, if you want Java people, you get 1 million of them. Right?
Yeah.
But we've also argued that like if you put out an ad, like we want Clojure programmers, they like come find you because they want that job. Is that your experience as well?
Yeah. Yeah, it is. And often they'll say, and I'm willing to take a pay cut, but you don't know what their salary is already. Yeah.
Well, it depends on what you're talking about. Are you talking about like entry level or junior mid-level programmers? That works really well. If you need to hire an architect, like a Clojure architect type person, then no, I don't find that that's true. It's much, if you're trying, I mean, the one thing I'll throw cold water on here is if you're, trying to hire people that are senior programmers with functional experience, that know Erlang, no Clojure, no F#, whatever, and there are not many of those in state, and you're trying to bring them in state, it's hard to get them to come to Louisiana because a lot of them have families and have kids, and there are a lot of barriers to getting those people to move here. And I know my company has had issues with that. Did you mention no fund?
I think it was mentioned in the intro.
Okay.
Yeah, but we have we have a meetup every Tuesday, first Tuesday of the month at Hack Night, which is at Launchpad. It's functional programming. We do talks. It's pretty successful. There's a nice core of people to come in. We're always looking for talks, so if you would like to talk about anything functional related, it doesn't even have to be really functional itself, but let me know.
Cool.